The day science begins to study non-physical phenomena, it will make more progress in one decade than in all the previous centuries of its existence. Well, rightly said by Nikola Tesla. It is this science that allows every one of us to never stop questioning, be it as simple as the invention of fire or be it queries related to black holes. Science is, in a true sense, a real infinity. That is, it has no ends. It is this particular thought on which AIChE NIT Rourkela has embarked upon, and through its regular K-12 sessions, tries to give insights on various STEM topics to the next generation of plethoric science enthusiasts like you all. Another day, another session, but the excitement level is all the same. Having said this, we welcome you all bright students and teachers to this wonderful initiative of ours, the K-12 Expo, a 3-day long science heist for the sharp schooling minds. In today's session, our topic of study is transfer of heat and states of matter. The intended class participation is from 6 to 8. Lots of things lined up for you all. But first, let's welcome our guest teacher, Mr. Gaurhari Ghosh sir from St. Paul's, Rourkela. So we hope that you will attend this session as well and provide us with your valuable insights. Great to have you on board. For today's session, we have with us Arshita and Nirmalya as my co-hosts. They will accompany you all on this insightful journey. So let's get started. So today's topic is heat transfer and states of matter. So the first question that arises is, why did we choose this topic? Yeah, let it be like this. Let it be like this only. Yeah. Okay. So the first question that arises is, why we chose this topic? Well, heat transfer seems very easy a word, but what particularly is behind this particular form of science? So let's know about it. Conduction, convection, and radiation are usually something that is tough to demonstrate. And though it is an important topic, students ignore them because of its unrelatability. Similar situation goes for states of matter as well. But in this presentation, we would like to take you through deeper concepts of both these topics in a visually interesting way. Hence, we took up this topic to help the students know how cool heat transfer and states of matter are. Next slide, please. Next slide, please. We are really sorry, guys. Like, we are facing some bad network issues, and that's the reason we are not able to share the screen properly. Uh, but still, we are trying our best. Please bear with us. Hello, am I audible? Like, Siddharth bhai, can you give me a thumbs up if I'm audible? Okay, guys. Actually, we are facing some network issues on our side, so that's the problem. Actually, we are not able to share the screen properly. Anyways, we are trying our best to do it. Just bear with us. Guys, we are starting another meeting, so please join that meeting. We are providing the link in the WhatsApp group again.
Wait a second,
Yeah.
Siddharth. I
So,
think the problem is sorted right now with MS Teams.
okay.
Let me try sharing my screen once more. And people, please hold on. Don't leave the meeting. We might just be able to get on with this.
Yeah, they're there. Almost all of them.
Okay, is my screen visible?
Yeah, it's visible. Yes, it's visible.
Okay, good. I think we can go on ahead.
Oh, hi, yeah, sure. Yeah. Go to the second, third page. Yeah. Yeah. Thank you. So, overview. So the topic why we chose. So this is the overview of heat transfer in a nutshell. Were humans able to boil water before we discovered how to make metal cookware? Well, absolutely yes. We have been boiling water in large cup-shaped leaves for thousands of years. We are able to pull this off because of a process called conduction and convection, whereby heat is conducted away from the leaf and into the water by convection. We'll be knowing about conduction and convection in some more time. So do you think it's possible to accomplish the same thing with a paper cup? In this module, we will explain how to perform this experiment in which we will boil water in a paper cup and will observe the results to understand the science behind it. So let's watch a video now, which our team members have made and I think that will give you a good idea about the experiment. Bhaiya, you have not shared the audio of the computer. Please stop sharing and again share with the computer audio.
Yeah, sure. Just a
Yeah,
second.
yeah. Yes, yes. Perfectly fine. Hello everyone. This is an experiment to demonstrate indirect heat transfer through convection and conduction. Let's get started. First of all, we need a regular paper cup. Make sure it is unwaxed, as wax can create complications by melting during the experiment. Then we need some water and of course a heat source like a heater or stove. We also need a pair of tongs to handle the cup, and most importantly, don't forget to wear your safety gear, that is safety gloves and apron. For the experiment, first of all, switch on the heater and keep an empty paper cup 2-3 inches above the flame. Now wait and watch. Well, you will find that the paper cup burns completely. Now repeat the experiment with 2/3 of water filled in the cup. Wait and watch. Surprisingly, this time you will find that the cup does not burn and the water starts boiling. The paper cup could easily have burned if it were empty. But as you can see, it has just procured little blackenings on its outer surface and nothing more. Now let's move to our presentation to know more on heat transfer. Thank you. Wow, oh, what a wonderful video indeed. Like pretty simple experiment uh, made understandable in such a short video. And thanks to the entire team for presenting this video. So with every experimentation, there are some set of safety precautions that you need to follow. In this particular experiment, you have to ensure that the paper isn't waxed, because if there is a wax coating on that paper cup, then it will catch fire, like the out exterior. Then you have to be careful with fire, of course. Then you have to wear fire protective gloves. Okay, and then you have to wear an apron that is fire protective. Then make sure not to touch the tongue directly. The tongue that you saw in the video shouldn't be touched directly. Then you have to also check the burner for any malfunction before the experiment. So these are the set of safety precautions that you need to follow while performing the experiment. Siddharth, can you please full screen the slides? Uh, at the bottom, you can see that there is a 3 dots will come, and then hello. Let's move to the next slide.
Is it visible now? Right?
Not yet visible for me. I don't know. Nirmalya can say. Yeah, it's visible now. Yeah, next
Okay.
slide, please.
Yeah, I'm on the next slide. Heat transfer in a nutshell.
For me, it's lagging a bit. Anyways, yeah. So, so You saw the experiment. Now let's understand the science behind it. Okay, so heat transfer in a nutshell. According to thermodynamic systems, heat transfer is defined as the movement of heat across the border of the system due to a difference in temperature between the system and its surroundings. So thermodynamics is a branch of physics and chemistry that you guys would be learning in your higher classes. So what exactly is heat transfer? That is, let's understand that with an example. Okay, suppose there is a hot body that is at a higher temperature, and there is a cold body that is at a lower temperature. Okay, so name them A and B. When you bring them in contact with each other, or there is any medium between them through which heat can pass through, then there is a heat flow from the hot body to the cooler body till both of them acquire the same temperature. Okay, so next slide, please. Next slide, please. Okay, okay. So now let's understand the different modes of heat transfer. So heat can travel from one place to another in several ways. The different modes of heat transfer include conduction, convection, and radiation. Meanwhile, if the temperature difference exists between the two systems, heat will find a way to transfer from the higher to the lower system. So as I already said, that when you bring a hotter body to a cooler body and there is a medium between them to propagate heat, then there will always be a method of heat transfer. Next slide, please. Now we'll be understanding these concepts, that is conduction, convection, and radiation in like briefly. So till the time the sites come, since we are facing some internet issues and technical issues, let's know more about this particular phenomenon. So we are heat transfer is a basic phenomenon in 6 to 8 class in science, in which there is a transfer of heat from one particular object to another particular object. The object with higher temperature, when brought in contact with the object in lower temperature, there is a transfer of heat, and based on that, based on the displacement of the particles, there are particularly three types, that is conduction, convection, and radiation. So now let's understand what is conduction. The process in which heat flows from objects with higher temperature to objects with lower temperature through the vibration of particles, molecules, without actual special displacement. So this is a typical form of heat transfer and takes place through physical contact. So whenever two bodies of different temperatures are brought in contact with each other, then this kind of particular heat transfer happens. In this particular type of heat transfer, there is no uh, displacement of molecules. Like every object is made up of atoms and molecules, but these atoms and molecules do not move while transferring heat. Rather, they only vibrate, and through these vibrations, this heat is transferred. Convection is the second mode of heat transfer. In convection, the transfer of heat is from higher temperature regions to lower temperature regions through actual motion of particles. So we understood conduction. Convection is slightly different. In this, what happens exactly is the particles, they actually move from one temperature region to another temperature region. Say from the hot temperature region to the cold temperature region, they move. And as they move, they help in transferring the heat from the hotter to the cooler region. It is essentially a process in which transfer of heat occurs via mass transfer of particles. Okay, next slide, please. Okay, radiation. Radiative heat transfer is the transfer of energy via thermal radiation, that is electromagnetic waves. It occurs across vacuum or any transparent medium. Thermal radiation is emitted by all objects at temperatures above absolute zero due to random movements of atoms and molecules. Since these atoms and molecules are composed of charged particles, that is protons and electrons, their movement results in the emission of electromagnetic radiation, which carries away energy. So radiation is a phenomenon in which the heat energy from the sun reaches the earth. Okay, so this is a very important phenomenon in nature. In this particular phenomenon, there is no need of any particular medium. Like the sun rays, they do not need any medium to come from sun to the earth. They can travel through vacuum. They can travel to any solid, fluid, or gas which is transparent. Okay, so this is another mode of transfer of heat. And yeah, like the rays that come, they are in the form of electromagnetic waves. Electromagnetic waves is something that you will be learning in your recent years, like in class 9, 10, 11, 12. So just know this much, that radiation happens due to electromagnetic waves. Next slide, please. So these are the three different modes of heat transfer, that is conduction, convection, and radiation. We will now look at some real life applications of this transfer of heat. So first is, okay, Arshita, you can take over.
Some of the real life applications of this transfer of heat, I'm going to explain it to you. So when you dip a spoon in a hot coffee, then the spoon also gets heated up. What is the phenomena behind this? It is the conduction of heat from the hot coffee to the spoon. And have you noticed that when the hot coffee is kept without any spoon inside it, then it takes much more time to cool than when the spoon is inside it? What's the reason behind it? It is because when you dip the spoon inside the coffee, then it is because when you dip the spoon inside the coffee, the surface area increases. That is, the tip of the spoon also starts radiating heat, and that causes the coffee to cool faster with a metal spoon in the cup. Then, as you know, the common example about the hot air balloons. The reason why hot air balloons are able to rise is because of convection. Convection, as you know, is the movement of mass. So the heater at the base of the balloon heats up the air, which moves upwards, and the hot air, being lighter, will fill up the balloon and thus cause the balloon to rise up and also move. And when you have to come down from the hot air balloon, you just have to, like, the pilot releases the hot air inside it and the cold air replaces the hot air, and therefore the balloon starts lowering down. Then is an example of formation of sea breeze and land breeze. It is an example due to convection. It is an example of convection. So by the definition, it is the movement of molecules at higher temperature which replace the molecules at lower temperature. You might not be knowing a fact that when the water takes more time to cool and heat up as compared to that of sand. You will read about this in higher classes about a term known as the specific heat capacity. So if a substance has more specific heat capacity, it takes more time to heat or cool than that with a low specific heat capacity. So in the afternoon, the surface of the land near the sea is warmer as compared to that in the evening. So convection causes the air which is closer to the land surface to heat and hence rise up. This warm air near the land is readily replaced by the cool air, and this is known as the sea breeze. When it is night, the tendency of the land to cool down is more. So the land gets cooled up and the hot air from the sea is replaced by the land, and this is known as the land breeze. So now let's start with the states of matter. So there are three states of matter, as you know: solids, liquids, and gases. These are the common states of matter, and you should also know that states of matter does not only depend upon the temperature, but it also depends upon the pressure. At room temperature and pressure, let's take a common example about water. Water, you know, it exists as a liquid, but if it is cooled, it converts into ice, and if it is heated, then it gets converted into water vapor. So let's distinguish solids, liquids, and gases based on their properties. Solids, they have a definite shape. Liquids and gases have no definite shape. Solids and liquids, they have a definite volume, but gases, they do not have a definite volume. What do I mean by this? Like, for example, if there is a container and gas is present in it, then it spreads throughout the container, and thus there is a change in volume. But liquids and solids, they have the same volume, even if it is kept wherever it is kept, irrespective of wherever it is kept. So solids, they have a high density, liquids have medium to high density, and gases have low density. Solids and liquids are slightly compressible, but gases, as you know, can be easily expanded and contracted. Uh, Here's a video explaining about the different states of matter, and then after this video, we'll explain you the terms in detail.
Via audio. Well, let's do with the video. Let's go to the other slide. Let's go to the next slide.
Swagat,
Yeah, it's doing good.
could you please move to the next slide?
Let's start exploring the objects around us. As you know for now that there are only three states of matter, which is solids, liquids, and gases. But wait, how many of you know that there is also a fourth state of matter, which is known as plasma? So be ready, guys, and focus here to know more about this cool but actually hot discovered state. You will know why we are saying this because when you will study about it further. Next slide, please. Yes. So a solid, as you know, is a closely packed particle substance and the particles can only vibrate. They have strong interactive forces between them. They have a definite shape, stable, and a definite volume. Solids can only change shape if force is applied to it. One more interesting fact about solids is that they have a different crystalline structures. Even if there is one like for example, you can see in this image that iron, it has different crystalline structures, even if it's called iron. What is the difference between their shape, structure, and sizes? Can you please move on to the previous slide? Uh, Let me explain you about some crystal lattice. Uh, Here, as you see in the figure, like solids, there are some small circles which are known as, you can call it either ions, atoms, or molecules, depending upon the element. Then, next slide, please. Uh, so, like, therefore, depending upon their arrangement, there are different crystal lattices. This is the reason why iron has different forms like pig iron, wrought iron, malleable, nodular iron, gray iron, and white iron. These shapes, I can give you some examples about these shapes. You will learn about it in higher classes. It's known as the body-centered lattice, space-centered lattice, and also one more example is edge-centered lattice. Solids can also transform from one state to another. Next slide. Then is the liquid. A liquid is a fluid that conforms to the shape of the container, but that retains a nearly constant volume independent of pressure. Intermolecular forces exist, but they are not as strong as solids, and the molecules have enough energy to move around, which makes the structure mobile. In the picture, you can see that the molecules are always in random motion. This is because they have less intermolecular forces between them compared to that of the solids, where they could only vibrate. Therefore, the structure becomes more mobile as compared to that of the solids. This means that the liquids have no definite shape. Liquids have no definite shape, but their volume remains the same. It does not change. Its volume is usually greater than that of the corresponding solid. It is said this because any substance which melts, their volume increases, and therefore it is said that its volume is usually greater than that of the corresponding solids. Except in case of water, where ice, like if ice melts, then because of its anomalous property, it contracts. Next slide. Gas molecules have either very weak bonds or no bonds at all. So they can move freely and quickly. Because of this, not only a gas conforms to the shape of the container, it will also expand to fill the container, thereby changing the volume. Gas molecules, they have enough kinetic energy that the effect of intermolecular forces is small. As you can see in this picture, that they have very random motion. They have very random motion throughout the space, and they have enough because they have the kinetic energy in them, and they have no intermolecular forces because of their kinetic energy. Let me explain you what is kinetic energy. Kinetic energy is an energy which is present and it helps the substance to gain some velocity. You might have learned it earlier. I was just giving you a brief overview about the kinetic energy. The typical distance between the neighboring molecules is much greater than the size of the molecules themselves. This is also a thing which you should know. It's something interesting. So I would hand over now to Nirmalya Didi. She'll take over.
Am I audible?
Yes.
Hello, folks. I'm Nirmalya. Uh, Next slide, please.
Is it visible?
No, not this slide. Next slide. Hello,
It's visible
everyone.
now.
Yeah. As my fellow teammates Arshita explained you about three phases of matter that existed in the universe, that is solid, gas, and liquid. Did you get them all? You can raise your hand if possible. Yeah.
Like many of them are raising hands.
Yeah. So I know you would. As we know, as we know that water boils at temperature 100 degrees Celsius, and at this temperature, water actually changes its phase or transit its phase from liquid to gas. So, but have you ever wondered that what happens if you raise the temperature to super high level, like between 1000 degrees Celsius and 1 billion degrees Celsius? Will everything just be a gas? The answer is a big no. If any of you know the answer, can raise your hand. Like, what will be the answer of this? Yeah, I can see many of you are raising their hand. Okay, so the correct answer for this, that plasma will form. So plasma will be formed at this high temperature, and this actually the birth of the fourth state of matter, and that is very new, like to all of us, and that's called plasma. Next slide, please. So let's know more about plasma. Yeah. So what is plasma? Plasma is actually a superheated matter, so hot that can like there is so much noise. Yeah, thank you. So plasma is a superheated matter, so hot that the electrons are ripped away from the atom, forming an ionized gas. And the temperature that is needed for making the plasma at this temperature is actually gained from fusion energy from the nature. And the fusion energy is basically when two atoms fuse together. So they gave up some energy, and that energy is basically used to increase the temperature to such a high level. So basically, plasma is a state of matter where the gas phase is energized. That means it gains some kind of thermal energy until the atomic electrons are no longer associated with any atomic nucleus. That means electrons are leaving its orbit, and what we have the charged ionized nucleus. So plasma are made up of positively charged ions and unbound electrons. Plasma may be produced by either heating a gas until it's ionized or by subjecting it to a strong electromagnetic field that actually help the plasma to have like the gas will be having that energy and it will be converted to the plasma. Heating matter to high temperature cause the electron to leave the atoms, resulting in the presence of free electrons. Like a gas, plasma does not have the definite shape or volume. But unlike the plasma is electrically conductive because of the free unbound electrons. And it can produce magnetic field and electric current of its own and respond very strongly to the electromagnetic forces. But the plasma state is often misunderstood, but it is actually quite common on the earth, and surprisingly the 99% of the visible universe actually comprises of plasma. Like you can see also in your surrounding that many example are also of plasma, like that branch of lightning that cracks the sky is plasma. So are the neon signs along our city streets, that are also plasma. And also the stars you see in the winter nights or the night sky, that plasma glows in the form of like stars, nebulas, even the auroras that actually ripple around the north and the south pole. So our sun is also the star, and that makes life on the that makes life on the earth possible. That is also the example of plasma. And because so much of our universe is made of plasma, this is the behavior and the properties of the plasma are the areas of immense interest for the scientist, and like in many disciplines. And other researchers pursue plasma for making computer chips, rocket propulsion, also the cleaning the environment and destroying the biological hazards and healing wounds and many more exciting applications. Next slide, please. Okay, so now we completed the plasma. Now we are going to learn about phase change. Arshita already explained that the three phase exist normally, like the solid, gas, and liquid. Now we are going to learn about phase change. So what phase change actually means that the matter change it state from one phase to another, and by changing the phase it is actually changing its property, because the chemical bond involving the atom, like they also get changed. And matter actually changes state when it is heated or cooled. But do any of one you know that why heat is the key behind all of this? You can raise your hand if you know the answer. Yeah, yeah. So let me give the answer. Because when the material is absorbing some kind of heat energy, the attractive force that exists between the molecule, that is changing. So that leads to the rearrangement of the particles, and that actually the driving force behind the phase change. So heat is the driving force for the phase change. And do you want to know what the process of phase change is called and how heat is involved in the process? So here is the slide like that explaining that first one is solid to liquid transition, that is called melting. and here heat goes into the solids as it melts, and liquid to solid transition is called freezing. Freezing is just the like opposite of melting, and heat leaves the liquid as it freezes. The next one is liquid to gas, that is called vaporization. It both includes boiling and evaporation. Boiling and evaporation are two different phenomena. Like boiling is the bulk phenomena, that means the bulk of the matter is getting boiled, and the water is changing its phase from liquid to the gas. But in evaporation, only the surface molecules of the water, like if the water is the matter, then the surface molecule of the matter is actually going to the vapor phase and not the bulk. So that is called evaporation. And here heat goes into the, in both of the process, heat goes into the liquid as it vaporizes. The next process is gas to liquid, and the process is called condensation. Here heat leaves the gas as it as it heat like heat is leaving from the gas as it is condensed. So next is solid to gas. So here solid is directly changing its phase from solid to gas, and that is called sublimation without going to the liquid phase. Here heat goes into the solid as it sublimes. And next slide, please. So also in the previous slide, I want to remember one thing, that in the phase change, the mass is staying constant, only the density that is actually changing during the phase change. Now we are going to see some real life application. That is, first one is solids in ceramics. The ceramic bowls that we are seeing in our daily life are great example of a solid. Did you know that the piece of pottery make up many of the items found from ancient civilization? Ceramic materials are usually made from soft clay that is heated up and then slowly cooled. And after it is getting cooled, the clay becomes hard because the water that the moisture it has, that is not there, and the moisture is removed, and the chemical bond inside the clay is changed. Then the next step is measuring the water. Here water, it is water, it is the measured liquid. And the oceans, lakes, and rivers are good examples of liquids. Water, like the planetary scientists are looking for other planets that have liquid water, because water is a need to sustain life on any planet. So, but planets require very specific condition in terms of pressure and temperature to have water or to contain moisture as we know it. Next slide, please. Okay, so the next state is gas, and the gases in balloons. Balloons are technically gases because it comprises of gases. They are little piece of rubber. However, the helium gas inside the balloon is a gas. Helium is a noble or inert gas that has a very low atomic mass. That you know, that is 4 mu, and in its gaseous state, it is lighter than air. As it is lighter than air, it is having low mass. It is also having low density. So the helium gases have lower mass and lower density than the nitrogen and oxygen molecules that fill most of our air. You know that air consists of 78% nitrogen and 21 close to 21% oxygen. So so having low density, the helium actually float, and the mass and the lower mass and the lightness help the balloons to float. Next slide, please. Then the last state, the fourth new state that we know, that is plasma. So I also mentioned that in the example I also mentioned the plasmas on the sun. Basically every star consists of plasma. So plasmas are highly energized gases that have lost their electrons. Stars, including the sun, is covered in plasma. Hydrogen helium ions float around the sun with their electrons moving freely at very high temperatures, such as those present in stars. It is assumed that essentially all electrons are free, and a very high energy plasma is essentially bare swimming in the sea of the electrons. Well, that brings us to the end of our learning. So I hope that you guys enjoyed a lot, and we all learn a lot about heat transfer, like phase and three phases, the phase changes, and also the new state, the fourth state, that is plasma. And I know the schools are closed as of now, but this must be a charge up session for all of you. And thank you all for joining us and giving your time attention today. I also hope that you all are doing well in this pandemic. I would also like to thank my co-host Siddharth and Arshita for joining me. And thank you again for attending this amazing session of K-12 that AIChE NIT Rourkela student chapter has brought in front of you, and also for being so patient with us till now. So here in the right, you can see the QR code. You can scan it or visit our website. There we will let you know about our futures like session, and we can meet again and again with many events like this. Now I am handing over to Siddharth for taking us ahead with the session.
So thanks a lot, Nirmalia, and thanks a lot, Arshita, as well for helping me in this wonderful journey. It was really interesting, the entire event. Guys, please don't leave the meeting now. Uh, I have something important to say to you all. Before that, we have with us our esteemed guest teacher, Mr. Gaur Hari Ghosh from St. Paul's, Rourkela. Uh, he teaches science, specifically chemistry, from classes 9 to 12. And we are really proud of him for his mammoth task of teaching the new generations and propagating what he has learned from his teachers. And it's an honor for me as well and some of my friends here in NIT Rourkela that we have been taught by him. So, sir, the screen is all yours to address.
Yeah, thank you, Siddharth. I hope you all can hear me.
Yes, sir.
Well,
You are audible
yeah.
and visible.
So, good evening, students. As already Siddharth introduced me to you all, myself, Mr. Ghosh from St. Paul School, Rourkela, and my subject of teaching is chemistry. I teach chemistry to standard 9 to 12 in St. Paul's, and some of you may be knowing me, those who are Paulines, and those who are not will know me today. Okay, so I was just listening to the session that was conducted by these three students. Very nice and very enriching for the students of class 6 to 8. The modules were good, and I hope the students have taken a lot from this, and they will put forward in their studies all these things. See, the states of matter, it is a chapter, it is a session, I will tell. It is not only related to physics, uh, it is a chapter of importance. It is related to physics, it is related to chemistry, it is related to biology. All the field of science require this chapter. Matter is a very big chapter. I would rather say it is not cannot be just completed in one session. Lot of things are there to learn and understand. And if you love these things, naturally you will go deep into the science. Science is nothing but study of matter only. So I heard them; they were doing very well. The session was good, but I would like to suggest certain things to this session. You should add little more video and interactive videos. That will, I think, the students of 6 to 8 will catch because they are all getting last 2 years on online mode and lot of PDFs and lot of presentations are they are seeing. So I hope if certain little videos are added to your sessions, it would be a great thing. You are doing a great
Yes, sir.
thing. It will be better than that, I would let us say. Okay,
Yes,
students, if you
actually,
want to ask anything to me, you may ask. You may raise your hand. Siddharth will
yeah,
unmute you all, and you can ask me. I will help you out if you need to know
yeah,
something.
those who have any doubt, they can raise their hands and I'll give them the access to unmute. Okay, Mona Lisa, go ahead. Yeah, you can unmute yourself, Mona Lisa. Hello, Mona Lisa. Okay, then we'll go with Adishri. Adishri, you can unmute yourself and ask the doubt.
Yes, sir. Good evening. I have a doubt that if the gas changes to the plasma, then what the process will call that?
Conversion of gas to plasma. You want to
Yes,
know
sir.
the process name.
Yes, sir. And how does it happen?
It happens at a very high temperature. Okay. And
So
Siddharth will
what
say
happens to
something
the
on that.
molecules?
Yes, sir. See, that's the fourth state of matter, and that's basically a superheated form of gas only. Like at 100 degrees centigrade, water boils and water turns into water vapor, that is gas only. So that gas, like when this particular gas is superheated at 1000 degrees centigrade or billions of thousand degrees centigrade, then a formation of plasmas take place, and these are basically related to the protons, electrons, and the sun rays that we receive here. So these are all things which are made up of plasma.
So you know that sun is nothing but a ball of fire. Yes, sun has a very, very high temperature. So what is sun made up of? Sun is made up of the gases, basically the helium and the hydrogen gases. At very extreme temperature, what happens? This gaseous phase, it converts into the plasma phase. Okay, and if you want to get a name to that, there is no such name. I can say you can say it as plasmatization, the conversion of gas to plasma state. That much I can say you, but no such exact naming or process name is not there. That is, we just simply say conversion to plasma state. Okay, from one state to another, that is the fourth state. There are actually many more states, not only four states of matter. You are too small to understand all those things. There are at present, if I'm not wrong, 8 to 10 states of matter. But
Yes.
basically, when we talk about the states of matter, we are generally specified to solid, liquid, and gases only. Okay, that are the states of matter that are available at general conditions, at normal conditions. And to get another states of matter, say the plasma, the Bose-Einstein's condensed state, the fermionic condensed states, these all states, they require exclusive conditions to create. So generally at your age, you are confined to solid, liquid, and gas. That you understand well, it will help you a lot. Yeah, next question.
Yeah, Shreyans, you can go ahead. Shreyansh.
Good evening, sir.
You are
Hello.
inaudible.
Yeah.
Yeah.
Hello. Hello, sir. Good evening.
Yeah, go ahead.
Sir, I just want to ask that as in the presentation, sir said that sir, blood is of sir, blood is of two types. Is made of two corpuscles and plasma. Sir, what is the main function of plasma in blood?
What is the main function of plasma in blood? Blood is made up of,
Yes.
you all know, more than 95% it is water.
Water.
And the
Water.
remaining are the blood cells and plasma. Okay. What is the role of this plasma in blood?
So may
55%.
Yeah.
yeah, like I have answered to this. Yeah, so main role of plasma in blood is to take the nutrients, the hormones, and the proteins of the different parts of the body that they need. Okay, so they basically act as transporters. Plasmas in blood basically act as transporters. I think that answers your question.
Yes, I am clear. Thank you.
Yeah. Next, Samriddhi, we will take one question more because we also have time constraint. Yeah, sir.
Yes,
Yeah.
sir. Good evening. Sir, I have doubt that is there any difference between the plasma that is converted from gas to plasma and the liquid and or the fluid that is present in blood?
Yeah, like of course there is a difference.
Lot of differences.
Yeah,
Yeah.
I would like to add. Yeah, this the plasma that we are saying about the state of matter, that is quietly different from the blood plasma. Okay, as sir mentioned that our blood is made up of corpuscles like RBC, WBC, and platelets, and the plasma. So plasma is the fluid medium. The state of plasma is actually fluid, and the it is a fluid medium that carries the nutrient and the cells with it. And the plasma that we mentioned in the slide, like the state of matter, that is the fourth state of the matter. When the gas is heated to such a high temperature, then the atom inside the molecules actually lose its identity as an atom, and it is forming like a bare electrons, and the rest is nuclei. So that, I think that clear your doubt, right?
Don't confuse the plasma state of matter with that of
Yeah,
plasma of blood. Both are different.
yeah,
Okay.
yeah, yeah.
So you may be thinking, sir, यहाँ तो टेम्परेचर इतना हाई नहीं है, कहाँ से प्लाज्मा बन गया ब्लड के अंदर? That plasma is not the fourth state of matter. I would rather say that is what I would say is a part of the fluid, that is blood. Okay, it is not exactly the plasma, that fourth state of matter. You don't consider it as a fourth state of matter, is it? So that we can consider it.
No, sir. Like not exactly that blood thing. Yeah, we can't. Hello.
Okay, Samriddhi.
Yes, sir. Yeah. Okay, sir. Actually, we also have time constraints, so that's the last question we took. And so, thank you so much, sir, for attending this session and giving the students a valuable thought to think upon and inspiring them. We are really thankful from the AIChE family as well, so that you joined amidst your busy schedule. Yeah, thank you so much, sir, for joining and showing us your support.
Okay.
We would like to have you.
Thank you, everybody.
Yes, sir. I will take a picture. So those who are able to put on the cameras, they can turn on the cameras. We'll take a picture now. Yeah, thank you so much, guys. Okay, so now an important thing to say. Just a minute. Yeah, so after the webinar is over, guys, don't leave that WhatsApp group. We will organize a quiz on 30th January in the evening for classes 6 to 8 students. And those who will do well in that particular quiz, they will receive certificates. Don't panic. The quiz is not at all related to your school or school marks. It is a fun event for you guys. Just kind of relax between the hectic studies that you are doing at your school. Yeah, so don't leave that WhatsApp group. We'll send the meeting link there, and you have to come inside MS Teams again and then attend the quiz and perform well so that you can get a certificate. And about this session, the recording of the session will be put in our YouTube channel. I'll be providing the link of our channel in the WhatsApp group itself. You can subscribe our channel and then you can watch these videos again. And you can also find the previous sessions recordings. And yeah, like as Nirmala mentioned, you can also visit our Instagram page. Those are there. I don't think many of you will be there, but those are there. They can visit our Instagram page and can follow our page and know about our future sessions and all. So thank you so much, guys, for joining in. We really appreciate your participation. And yeah, like we hope that you all join us in our future sessions as well. Thanks for being patient with us amidst all the technical issues. Thank you so much. This is really a nice session. Yeah, Ghosh sir, would you like to add something? Hello,
Yeah.
sir.
Yeah, thank you, Siddharth, and
Yeah.
your team for inviting me. I love to attend such sessions and webinars. Nowadays, it is called a webinar. Otherwise, it would have been a seminar. And I know seminar is far better than webinar, but due to concern of COVID conditions, this is the mode of life. You should get adapt to this. Okay, we all should get adapt to this. Okay, nice doing. Bye bye. That's all.
Thank you so much, sir, for joining in. Okay, students, you guys can leave now. And if someone has any doubt, you can stay back. Rest of the students can leave.
Bye, sir. Thank you, sir.
Yeah, thank you. Those who have doubts can stay back, else they can leave. We'll give them access. Okay. Okay, so Suruti, you can unmute yourself and ask what's your doubt. Okay, so DS left. Samriddhi. Samriddhi, you can unmute yourself.
Yes, sir. Sir, I have doubt. Another doubt. I can't ask that time, so I asked this time. So, sir, I have doubt that I am not clear in what is radiation.
Okay, so radiation is a mode of transfer of heat in which the molecules don't move, neither like there is no particular need of molecules in that. Okay, so what you need is two bodies only, and one has to radiate the rays, and you don't need a particular transfer medium as well, like the radiation rays, the rays that bring the heat can travel through vacuum, can travel to transparent solids, liquids and gases. It is the phenomenon by which we receive heat from the sun. Okay, so like when you are out in the morning or in the afternoon, the sun rays uh, like heat up the earth. So that's the thing. Okay, and like it is related to electromagnetic waves and all that you will be learning in your higher classes. So for now, just remember that it is a mode of transfer of heat in which you don't need any particular material medium for the transfer. Yeah, that's it. Okay, next is Kundan. Yeah, Kundan, you can go ahead.
So
And
my doubt is what is difference between plasma and gases?
okay, so this has already been answered. Anyways, plasma is a superheated form of gas only. Like when we boil water at 100 degrees centigrade, gas is formed. But when we boil this, but not boil actually, we heat it up to 1000 degrees centigrade or any other temperature that is above that, then plasma is formed. So like scientists consider it as the fourth state of matter, and so do we, because we are also learning what the scientists are discovering and inventing. Okay.
Sir, I have a
Okay,
doubt.
sir.
Okay. Yeah, go ahead,
Sir, I
Prabhudatta.
have sir, solid change in liquid. Can plasma change into radiation or radiation change
Uh,
into plasma?
See, like every particular topic that we study in, that is being researched these days. Okay, so there's no particular like theory that plasma changes to radiation and radiation changes to plasma, but things are going well in the experimentation part. Soon you would get to know in the news whether plasma changes to radiation or not. Okay. Till date, it's not possible. Yeah.
Okay, sir.
Yeah. Shreyans Das, you can unmute yourself.
Uh, Hello, sir.
Yeah, go ahead.
Sir, I wanted to ask that is plasma same for all?
Like,
Means in the case of the blood transfusion, uh, A antigen can give to his blood groups. So, if by
see,
mistakenly,
plasma has no
if-
particular role in that. It is basically the antigen that determines the which blood group will be transferred to which blood group, and it's not the case of plasma. Plasma is basically a transport medium in which hormones, proteins, and all nutrients are transferred. Like it carries all these things, and with water and hemoglobin and all, it just transfers these particular things to one from one organ to another organ. Okay.
means sir, I just wanted to ask that sir, you might have heard in between this pandemic time, plasma has been transferred from one body to another of patients. So, mm, is there any time? So different blood groups can get different blood types of plasma.
Uh, no, you didn't get me. Like I was telling what that depends upon the antigen. Okay, so the antigen will determine the transfer of blood from one particular donor to the receiver. Plasmas is all the same for all the bloods. Like it's not. See, we are not into biology. Like we are doing our engineering
Okay.
things. So
Uh, yeah, I can answer this. So plasma basically contains cells, okay, RBC, WBC, and it contains WBC, okay, and WBC is responsible for producing antibodies actually. Because it is called that it is the fighting cell of our body, okay. So that's why the plasma donation is being there so that we can transfer the antibodies, okay. That I think clear your doubts.
Okay, ma'am. Thank you.
Yeah.
yeah, so there are no more doubts, I feel. Okay, so you guys can now leave the meeting. It's over. We'll provide the recording in the WhatsApp group.